Hello, this is TJ and welcome back to my new video on Mastercam tutorial. And today I'm gonna talk about how we can create a custom profile tool in Mastercam, or we can call this custom tool. Mm, mm, mm. Before we start, let's talk a little about custom tool. As you know, in your programming work, there's sometimes you need to use some custom profile tool. Yes, maybe on the park we have some specific profile that needs a custom tool in order to machine, um, or sometimes um, we want to use the custom tool to save the machining time. And in simulation, if you don't define a correct profile, if you do not define the correct geometry of the tool, you will not get a correct simulation. So you are unable to see how the part look like after it's cut with the custom tool. Okay, so the defining of a custom tool is very important. And today I'm gonna show you how we can do that. Okay, how we can define a custom tool, and is there any rule for creating custom tool. I will cover in this video. Okay, yeah, about another thing, you can see before we start, you can take a look on the sample park. This is just a sample park for demonstration only. It's not a real park. You can see here on the park, on the top face of the park, I have an orange roof, and when I look from the front, you can see the profile of the roof here. We have some small undercut areas here, so the normal ball and you cannot get into, so that's why we have to use the custom tool. Okay, and next we can take a look on the left side of the park. We have some areas that that's a we call the undercut areas. That's that that's the areas the tool cannot get into, like this. If we machine this part on a 3x machine, and we finish these areas with a ball and mill, you cannot uh, reach into these surfaces. So if you machine with a ball and mill, you need another operation, and you put a part like this, and then you do finish cut with the ball cutter here in this direction, and it take a lot of time. Yes, and you lost one operation. That's a waste of time. So if you have a custom tool, you can run these areas in just one operation. Oh shit, remind me. Okay, so you can see if we use a custom tool, you can machine this area in just one operation. That's cool. That's why we need custom tool in some time. Okay, in Mastercam, to define a custom tool, we have I think we have three methods. The first one, okay, let's talk about the first one. The first one is you draw the tool profile right on Mastercam. Yeah, when you know uh, the dimension, the geometry of the tool, you can draw it on Mastercam, like I did like this, and then you can save it. You can save this profile onto another level. Yeah, maybe yeah, you move this profile on into another level, And then when you create a new tool, when you define a new tool like this, you can link the profile store in that level to use as the geometry of the tool we are creating. Yes, that is the first method. The second method is you can use the DXF file. Yeah, you can see uh, let me take a look. Yeah, you can see this is the DXF file. You can use this to define the geometry of our custom tool, but this method requires some Mastercam has some rule and maybe a policy. Yeah, I don't know how to say that, but let us show you. Yeah, this Mastercam has some guidelines for using a DXS file for a custom to define a custom profile tool, and yeah, it's to me it's quite complex. If you want to study about this, you can go to the Mastercam app here and search for DXF. You can see Mastercam have a section where it show you how we can um, yeah, how we can define a custom tool geometry using the DXF file. You can see we have yeah, some rules, some guidelines that quite complex. It's not simple, so if you want to study about it, just go to the Mastercam app. You can find it. Yeah, that is the second method using the DXF file. I will skip these methods because it's not simple. I don't want something too complex. Yeah, uh, something too some complicated. I don't like it, so we skip that method. You can read the Mastercam here for instruction. Okay, and the third method to create a custom profile tool in Mastercam, that's using the step file. Yeah, if you're working with 3D file, you will know what is a step file. I will try to see if I have some in my computer. Yeah, this you can see this is a step file. It has the extension is its extension sometimes STEP or STP. That is the step file. Is contain the 3D data of the part, and in Mastercam we can use a step file to define the geometry of our custom tool. Yeah, very simple. I will cover it later. Okay, so basically we have three methods of creating the custom tool in Mastercam. I'm gonna show you the first and the third method. The second method you can read in the Mastercam help section. Okay, alright, alright. Now I'm going to talk about the first method to create our custom tool. Yeah, that's a we use a defined geometry stored in a level, and we link that profile into the tool when we create a new tool. Okay, right, we can see first I have some level, or level 1 contain the park, so I will hide it so you can see it easy. Alright, and then I can turn on the la 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 la, I can turn on the X. Okay, so this is the origin. Yes, this is our origin. Okay, now I will make an example so you can see how we can draw the tool profile and how we create a tool with that the profile we created. Okay, we go to the wireframe, and for example I will draw a tool profile. Okay, oh sorry, I will create a new level number 3. Okay, so I will name it the custom tool number 1. Okay, now we are in the level number 3, custom tool number 1. Okay, and then you can draw the tool, maybe something this I will create a dovetail cutter like this. Yeah, you can draw what you want. And there's something you need to remember. Okay, the center of the tool should be at the origin like this. You can see this is the center of the tool. You just draw the half profile of the tool. Do not draw the full profile of the tool. It will not work. Okay, just draw. You just need to create the half profile of the tool like this. You can see this is a dovetail cutter like this, and you draw a half of the tool. For example, if you have the tool diameter is half inches, so this should be 0.25. Yeah, and yeah, so I will check the radius of this tool is about 7 millimeter, so that means the diameter of the tool is around 14 millimeter. Okay, something to remember, you need to draw the tool in the first quadrant of the coordinate system. You can see this is the origin, this is the y-axis, this is the x-axis, and this is the first quadrant, this is the second quadrant, the third quadrant, and the fourth quadrant. Okay, we have to create a tool, we have to draw the tool in the first quadrant. Yeah, that's like this. You cannot draw the tool around here, around here, or around here, just in the first quadrant. Yeah, okay, you can see I have number 3, level number 3, that contain the geometry of our tool. Okay, I can do some fillet here, yeah, if you want. And you need to remember the diameter of the tool in this case is, this is the radius and the diameter is about 14 millimeter. Okay, you need to remember the diameter of the tool. And the next step, you go to the toolpad and you go to the tool manager, and then we are gonna create a new tool. Okay, to create a new tool, you just need to select create new tool here. And for custom profile tool, you can select any of this kind of tool. Be face mill, you can select end mill, or you don't need to select custom tool. If you want to define a custom tool, you can select any of these, anyone will work. Okay, I can try end mill, and then you can see we have some basic parameter of an end mill, and we can use them to define our custom tool. So look at the window on the right here, you can see we have some button here that allow you to link your tool profile. Okay, the first button is let me read it: import and link to custom geometry from a level. Okay, this is the first method, using the created geometry stored in a level. Okay, in a specific level. I click on this button, and you can see we have the select level window open. Now you can select the level that contain the geometry of the tool we want to create. So you can see when I click here, it show level number 3 and level name is custom tool number 1. Then I'm gonna click OK. You can see we have an error here: problem with custom geometry data align segment on y-axis. That means Mastercam do not allow you to create any segment on the y-axis. So we're gonna back, so this line is forbidden. You cannot draw this vertical line, you have to remove it. Yeah, and this is the tool profile. Yeah, just only so. I will hide the coordinate system so you can see it clearly. La 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 la. Okay, you can see this is the custom tool. You cannot try draw this line. If you have this line, Mastercam cannot recognize the tool profile and you get an error noted. So remove this vertical line and we back to the tool manager, and then we create a tool again, go to create new tool, and then we select end mill. Now I will select ball mill. You can see it's the same. No, not important what type of tool you selected for custom. Okay, click on this button again and select level number 3 again, and okay, yeah, you can see la 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 la. You can see we have the right diameter of the tool around 14 millimeter. Yeah, and you can make it longer by increase the overall length, maybe in this case 40 millimeter, like this. Yes, so that's how we um, retrieve a geometry to define the custom tool. You can select end mill and you can select the level. Yeah, no problem. You have to uh, use the correct value of the cutting diameter. If you input a millimeter, this diameter will be used for calculation and the tool uh, will cut not correctly. So you have to input the correct value of tool diameter. In this case, I will link it again, and we have the correct dimension. Okay, so you can see, very easy, very simple. We have successfully created a custom profile tool. Very simple, right? Okay, this is the first method. All right, we back to our park. All right, now for practicing, I will create a custom tool to machine these areas. Yeah, these green areas. Okay, first I need to find the profile of the tool we need to make. Okay, I look the part from the front, and I make a new level, maybe number 4. Okay, or I can use level number 3 if you want. Yeah, we have no entity in level 3, so we can use the number 3 to create a tool to machine this green area. Okay, I use some wireframe function to find the profile of the surface here. Okay, this is profile we have. Make it, yeah. Now I can extend this arc. Okay, I will extend it a little bit. Tang, 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 tang. Yes, and then I draw a straight line here. This is the largest section of the profile. So if I want a tool with diameter is 20, I can draw it and input 10. Yes, so this is the radius of the tool, 10 millimeter. Okay, I also want to extend this a little bit. Yeah, so we have the clearance between the between the shoulder of the tool with the wall around here. Okay, right. Yeah, something like this. Okay, and we do some trimming and trimming. Yes, very simple. We remove the unnecessary line. Okay, and we do some trimming. We remove this line. Now I move this out so you can see. Let's see, we have something wrong here. Yeah, we have some duplicated chain. Okay, so I create a tool profile like this. Yeah, this is correct tool profile. Remember, you don't you can draw this line. If you have this line, Mastercam will not recognize the tool profile, so delete this one. Okay, you can see I will check the diameter of the tool. This is the radius of the tool, 10 millimeter. That means the diameter is 20. Okay, you can make it longer like this. Yes, no problem. Like this. Okay. And now the next step. Remember what we should do. Okay, we uh, we go to the top plane. There's one thing I forgot to tell you that when you draw some custom geometry, you have to draw in the top face. That means the X and Y plane. Yeah, like this. This if we draw in the front face, so we need to rotate the profile 90 degree like this. Okay, and I'm gonna turn on the X again and the origin, and then we'll turn off the park. So now we can move the tool tip center to the origin. Okay, and we go back to the tool manager. Now you can see we have tool number 2. Okay, we mark it to number 2, and this one is and this custom tool is, I need to link it again, number 3. Yes, and we override the old profile. You can see this is the new profile of the tool. Yeah, you can see the true diameter is 20. That's what we want it have. We want it to be. You can change the length of the tool, no problem. Like this. Okay. So we already create a tool. Now you can turn off this level and you can modify it whenever you want. Okay, I turn on the park, and now I will make some contour tool path to machine these areas. Okay, okay. I go to the contour before I cut this. um, I need to create a path for the tool. Okay, we'll run this time to make some trick. Okay, I need to find the path for the tool. Okay, level oh, path. The number 2 level contain the the path for the tool. Okay, I will close this up. Okay, I want to find the center of the tool. Alright, I got this point right here. Okay, look from the top, and I draw the line around here. I will trim this line around here. Okay, so you can see we have a line here for use in the contour tool path. Alright, we go to the tool path and go select, we're gonna select contour, pick one line. Okay, we have a chain, and I'm gonna select uh, our custom tool. This one, it should be number 3. Yeah, it should be number 3. I name it cus D20 custom tool. Okay, forgot about the speed and feed rate is not important in this case. Okay, and I select computer. I select this line for contour, so I will I need some lead in and lead out definition first, and then okay, let's take a look. You can see this is the tool edges, so it's contact with this line. So if I will go, if I want to move this here to here, I should move this line. Dun, 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 dun. I should move this around here, or you can make it 20 millimeter, 10. La la la. Yeah, 10. And you move this line from here to here. If you want to cut using the tool center, if you don't want to cut using the tool center, you move this line to here. Okay, this is the new position. And now we regenerate the tool path. You can see we don't use we okay, 0 RAM. No, this should be 2D. Okay, and yeah, this is the correct position. You can see the tool we touch the park like this. This is the one passes. We can use multi passes. So yeah, is make everything easier. Okay, the first pass, oh, still too thick. Yeah, maybe we need more and more park, maybe 6 and 1 millimeter per passes, or you can measure from here to here and you, yeah, like this is okay. You can increase the here to 45. Okay, okay, this is the first case. We create a custom tool using the profile we link from a level. Now I will hide the level number 3, and then I create another level number 4. Okay, I will name it custom tool sorry, number 2. Okay, oh, sorry. Earthquake. Okay, uh, we still add the first method that we draw the tool profile and start it in a level. Okay, but with the with some geometry on the part, there is some standard, and if that is standard, you have the standard tool, and you can download the tool geometry from the manufacturing site. Okay, for example, I have a o-ring groove here, and this groove they have standard, yes, maybe standard of a company. So there are some tool manufacturer, they make uh, their tool. For example, the Harvey tool here, you can go to the product, specialty profile, and you can see they have the let me dovetail cutter, and this is the Parker Hanifin O-ring with drop hole provision. Okay, we select this one. Maybe something with the internet connection. Okay, you can see they make some la 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 la. Yeah, they make a tool for O-ring also. So they have a tool. We don't need to run our custom profile tool. We just need to download the tool profile and order it. Okay. Most of the tool manufacturer, they provide us the geometry of the tool in step or in 3D or 2D or 3D format, so you can use what you want. Let me check. uh, this is the tool I use for cutting the o-ring. Okay, o-ring groove. Yeah, and let me see if they have the simulation file. Yeah, you can see here there's something called simulation file that's contain the tool profile, so we can use it to define in our cam system. I click on this and you can see it's download the DXF file. Okay, and I mentioned before, because the use of the DXF file to define the tool profile is quite complicated, so I will skip it. But we will use this file to get the tool geometry. Okay, I back with the Mastercam and I go to file, merge. We will import the DXF file to Mastercam to get the geometry. Okay, we select the merge and we go to find the tool, this one, DXF. We open it. Okay, and let's see where is it. So here it is. Yeah, very small, very small. This is the tool profile. Okay, I will turn off the park so you can see it clear. This is the tool profile. Why it is so small? Is there something wrong? That's okay, because the Harvey Tony US manufacturer, so they make 20 in inch unit. So but my Mastercam, my at the moment I use the metric system for my Mastercam. So when we input the inch tool into the metric environment, it's become too small. So the first thing I need to do is scale it to the original size, the real size. We go to the transform and scale. Now I will scale it to 25.4, yeah, to convert from uh, into millimeter. Okay, now we get the real profile and the true dimension of the tool. You can check the diameter of the tool. This is the tool radius. Yes, this is tool radius in metric. Okay, and we do the same. We can use this profile to create a tool. Okay, this time I will try to put the profile uh, in the second quadrant. This is the first quadrant, this is the second quadrant, and this is the third quadrant. Now I put the profile on the second quadrant. Yeah, so let's see if we can define the tool with this profile. Okay, I move this geometry to level number 4. Okay, so level number 4 is contain the geometry to define the custom tool number 2 to cut the o-ring groove. Okay, now we back to the tool manager. and we create a new tool, and new, and then we select import and link custom geometry from a level. I select level number 4. Okay, click OK. So you can see we have some error. Yeah, you have some error. Crazy. Okay. That's fine. We keep that tool in there. Yeah, I think just because we draw the tool in the second quadrant, so it doesn't work. You just need to mirror y-axis, and we move. Now we change the tool geometry to the first quadrant, and now we go to the tool manager again, select number 4, link to the number 4, level number 4, and override the old tool geometry. Choo! Yes, this done. So you can see we have the tool right here on the window. You can change the pam 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 pam, the flute length and the shoulder length or anything. Yeah, but here there is very important thing you need to remember. You can take a look here and you see cutting diameter is about 3.175. That's around 1/8 inch. Yeah, you can see it take the same diameter. The same diameter is not take the cutting diameter, so this can be a mistake. In order to in order to make everything correct, you need to input the correct value of the cutting diameter. Okay, I will be back and check it. I do some measurement from this line to here. You can see the radius is 1.067. So this one, this diameter should be 1.067 multiplied by 2. Okay, now you can see we have the correct dimensional tool. You have to input the correct dimension of the cutting diameter. Okay, and we finish. Alright, and you can turn off number 4. Everything is complete. Now I'm gonna use the tool number the custom tool number 2 to cut this o-ring. Okay, this rule have a drop hole here, so it's allow you to drop the dovetail cutter here and do the contour. Shoo. Okay, I will turn on the part level and part. Okay, and we do some contour, select some entry point, and then I'm gonna select the contour. One second. And select tool number 4 and contour to these, depth, cut, lead in and lead out. Okay, I can use U entry point and U exit point. Go. Alright, this just for demonstration only, so I don't use the multi-pass. Oh, what's up, man? That's something crazy around here. Whoa. Turn off the multi-pass option. Yes, I think it's okay now. You can see the tool plug into the drop hole here, and it's do the contour. Right. Yeah, you need to make some adjustment. Go to level, turn on the custom tool number 2, and you have to measure the from here to here. Ah, shit, come on. Ah, crazy. Analyze distance from here to here. This is the delta x. I can copy that and I go to here, input. Okay, and let's see. I don't want to have an arc lead in and lead out, so I remove it. Now let's check. Look, plug into the drop hole and we go. I select the chain again, ping the point, and then select this chain. Okay, and another chain, another point. Okay, and another chain. All right. You can see the tool go to cut the o-ring. So this is for demonstration, so I don't use the multi-pass it. Okay. Okay, let's take a look on the park here. We can do the simulation. Okay, ten. This is the flat MU to cut the drop hole. Row. Yes, it cut the drop hole for the dovetail cutter to go down. Okay, then we have some ram motion like this, and see that this is our custom tool number 1. Let's see how it cut. In 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 Make it faster. Green, green, green. So you can see it cut pretty well. Okay, and now the next custom tool, the o-ring cutter, plug into the drop hole and it's do the cut. Okay, you can see I can turn on the workpiece. Everything is look good, nothing wrong. See? Okay, I will turn off the workpiece. You can see I will trim clip front. Yeah, you can see. Ting 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 ting. This is the look from the front. Yeah, this is how the custom profile tool work. It can also create a top fillet here. Yeah, very nice. See that? Okay, we back off. All right. So that's how you can see how I create a tool using the geometry stored in a level. Okay, that we link the geometry from a level to the tool profile. That is the first method, and the second method, yeah, it's quite simple, not so complicated. That we use the external step file. Okay, some tool manufacturer they provide you the step file for the tool for simulation, like here the Eastcar, a very famous brand. They have something called a high feed ray cutter like this one. You can see if you take a look on the insert here, you can see the sap of the insert is very special. It's not a standard. So if you want to do the simulation, you need to define this shape of the insert. Okay, but in programming, they also provide us something called the radius for programming. That means instead of you use the true model of the tool, you can use the tool as a bool mill with a radius. Uh, uh, with a radius they provided. Okay, when you click on more info, you can see they have radius for programming. That means it's not the true radius, because the sap of the insert you don't have the radius, but for programming you can use this value for a safe uh, safety. So it if you use this value for radius, it can make sure the tool will not hit the park. Okay, and like the Harvey tool, the car tool also, they also provide us the simulation file of the tool. Let me see how we can download it. Let me check it. We need to select a model, maybe a 16 millimeter. Okay, detail. This is a model of the tool. Yeah, yeah, yeah. Like this is the line model, so you can see this is the insert. This is the insert, and they rotate, so you have this shape. Now I'm gonna download this tool, this one, 3105. Okay, blah 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 blah. Okay, so the second method, in this method I'm gonna use a step file to use as a custom tool. Okay, we do the same. We go to the tool and we go. With this method, we don't need to create a level. We just need to link the external step file into Mastercam to use as the tool. We go to the tool manager and we create a new tool like we did before. Okay, I can select end mill, and now instead of using this button, you use this button. You can see import and link to custom geometry from a file. You click on this and see what type is support. You have DXF, step, and Mastercam file. Yeah, you can start a profile in any of these file type. Okay, now I have to look for a tool. Okay, this one. I click on this, and we wait a little bit for Mastercam to calculate the geometry of the tool. So here's the, you can see after we import the step file, you can see we have the tool with the correct shape of the insert here. We don't have to use the bool mill anymore. We have the correct profile of the tool, so you can see the the diameter is correct also. It's 60 millimeter. Yeah, everything is fine. Everything is okay. Yeah, yes. So uh let me do mm, a contour with the tool we just created to see for you to see. Okay, I will back and do it again. You just need to click on this button, import and link custom geometry from a file. Click on this and you select the step file, and you got a tool very quickly. Okay, now I use that tool to cut a contour. Okay, I will cut this contour. I select this tool. Alright, and we'll go maybe drawing the minor 3. Oh, no, 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 no. Minor 2. Okay, minor 2. No depth cut. Let lead in and lead out. Computer. Alright. Let's see. Ooh. Wrong tool. Let's select another one. This one. Ping. Tang, 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 tang. What's up? Okay, maybe minus 10. We'll cut this a little bit deeper so you can see if the tool profile is worked or not. Alright, we back to the simulation and we cut with the ISCA custom tool. Oh, the tool plug into the park. Cut. You can see we have the correct simulation, we have the correct shape of the insert, so we have the correct simulation result. Here you can see it's totally different with a bone mill. It's not like a bone mill, yeah, it's a high feed mill. So this is the shape of the insert. Yeah, very nice. I think that's all we have for today. Let me check if we forgot something. Blah 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 blah. Okay, let's do some uh, summary. The So in this video, I just show you we have three methods to create a custom profile tool, but in this video I just focus on the first and the third method. The first method, we draw the tool profile and store that on a level, and after that when we create a custom tool we will link the geometry from that level to the tool profile. Okay, and the second method is we use external step file. Yeah, you can download the step file of the tool on maybe every tool manufacturer website. They normally provide the 3D file of their tool, especially the indexable tool. Yeah, that's mean the tool with insert. So you can link the park file, the step file to the tool profile. Very simple and yeah, quick. Okay, I think this video might be very quite this video is quite long. It take about more than 1 hour, I think. Wow, but I think I hope this video can help you in some case where you want to create a custom tool for your project. Okay, alright, thanks for watching. Goodbye for now. Good night.